Ladies and gentlemen, please welcome to the stage a representative from ANYbotics.
Good afternoon. My name is Paul Bingaman. I'm with ANYbotics, and I'm assisted today by Luka Angelic. He's going to be walking in with our robot here in a moment. He's our professional dog trainer for today. ANYbotics is a developer of legged industrial robots. They're used in a lot of different ways that I'll talk about, and I'll introduce you to the robot, its components. The robot is a part, it's a physical and an intriguing part of a broader system of hardware and software that we deliver to customers. And I thought I'd start today with a 2-minute video that I'll speak over that shows our system in a real-world use case, a very common one, which is the inspection of an electrical substation. Now, this is a fully autonomous mission. The robot is in a shelter, and this video is sped up about 8 times real time. It's a 16-minute inspection of a substation, and what you'll see is that the robot navigates all by itself from one navigation point to another, and at each point it has various pieces of equipment that it's collecting visual images from, thermal images, and even acoustic profiles. It can take recordings of transformers, of electric motors, pumps, and the like. And you can see here that the robot can navigate very precisely through this complex facility. Here in a moment you'll see it walk over a gravel pile that's about 1 meter high. No problem at all. Our robots are very agile. Here you can see it's navigating a mud pit that was set up as an obstacle. And the robot can walk on all kinds of terrain. Of course, what we have here for terrain today is very simple, but the robot can climb stairs. It can go almost anywhere that a person can go in an industrial facility. And as you can see in the video right now, it can also crouch down low and crawl underneath some equipment and inspect from below. But in each one of these locations, it's deploying its sensors to collect data from sensitive equipment, and that data, in some cases, is immediately analyzed on board in real time to determine if the temperature or the reading on a gauge or a digital readout is within specifications or not, and it can raise an alarm if there's an anomaly found in that process. One of the other things that the robot can do is determine if necessary safety equipment is in place where it's expected. And here you can see at the end of the mission, the robot goes back into its shelter and docks automatically to recharge to prepare for the next mission. And here we have Animal. Animal is, as you can see, the size of a large dog, weighs about 110 pounds. And this is a standard configuration. We have 2 models. This is our Animal D model, which, as I mentioned, I think earlier, is an IP67 rated machine, fully waterproof, dustproof, ready to work in dirty, wet environments. Has a wide operating temperature range. We have these working in very hot desert climates as well as cold, wintry climates. One of these robots has worked for years in a substation in Switzerland, year-round in snow and all kinds of weather. And just to review the anatomy with you, you'll see, of course, we have 4 legs. Each leg has 3 motors, and we have opposed knees. If you've seen other legged robots, oftentimes you see that the knees face backwards, but we have the knees opposed in the middle, and that gives us a very symmetrical agility. We can walk forwards, backwards, side to side. Regardless of direction, the dynamics are the same. A few of the other anatomy pieces that are interesting, we use LiDAR here on the rear to continuously scan the robot's spatial environment, and it compares what it sees right now with the model that it has stored from a prior training session that we performed here. So it knows within centimeters where it's located at all times. And then on the top here we have the standard inspection payload, which is a fully integrated payload containing the most common sensors that we use for industrial inspection. And that includes a visual camera with a 20x zoom lens that can take still images as well as videos. We have a thermal camera. We have an ultrasonic microphone that's very effective at listening to electric motors, gearboxes, bearings, pumps, and the like. And then we also have a very bright spotlight that allows the robot to take pictures and shoot video even in dark corners in factories, dark tunnels, and outdoors at nighttime. Other features of the robot that are kind of interesting, it has a wide-angle camera on the front and the rear, and it also has 6 depth cameras. And the depth cameras look at the ground all around the robot, and as it's walking, it's constantly evaluating its surroundings to decide where it's going to put its foot next. It really works just like we do, constantly evaluating its surrounding, planning where it's going to step, expecting what it's going to step on, and then evaluating if its expectations were met. One of the interesting things is when the robot walks on the snow, it sees a surface, and then it quickly realizes that its foot doesn't stop on the surface, and then it has to reassess, where's my foot actually stopping? And so it operates much like we do. The interesting thing, and I'll show a little video clip later that illustrates it a bit, but all of the robot's ability to walk is actually trained using AI in virtual environments where we can deploy thousands of virtual robots that are forced to learn how to navigate challenging terrain in a virtual environment, and then we score their performance and we take the most successful algorithms and put them on the robots in reality. And it's proven to be a very successful way to essentially evolve the robot's ability to walk in a rapid way. So let's move on with the presentation here. Thank you very much, Luca. So today we're at a very interesting inflection point in the evolution of robots in our commercial lives, I would say. We're all familiar with robots that have been used in manufacturing for a long time, typically fixed robots that perform repetitive tasks over and over. And then we've moved over time to more mobile robots used in warehouses for moving goods around, especially in the high volume e-commerce warehouses fulfilling orders. And moving forwards now, we're moving into more autonomous mobile robots like ANYmal that can take over repetitive, mundane tasks, and often tasks in hazardous or unpleasant environments. Our robots are used by customers in the mining industry, in metal manufacturing, in coal-fired power plants, chemical plants, oil and gas facilities that often have unpleasant working environments. Sometimes they can be very hot, they can be very humid, wet, dirty, you name it, cement plants. And we like to take people out of these mundane, unpleasant, uncomfortable tasks and have them focused on things that only people can do. Things like troubleshooting equipment, repairing equipment, doing data analysis and the like. Our robot's going to go almost anywhere that a person can go in an industrial facility, and it can take over that repetitive, mundane inspection work that needs to be done, but most people don't enjoy doing it. Of course, if you look around industry, most facilities still depend on humans being present and performing important tasks. And that's despite the fact that most of the markets that we serve are characterized by workforce shortages. Most of our customers can't hire as many talented people as they need to run their facilities effectively and are constantly struggling to fill important tasks in their facilities. And that's where our robots can really help by stepping in, taking over some of the more mundane tasks and freeing up talented people to do tasks that only people can do. The other thing, it's a simple reality, is that a lot of the repetitive inspection tasks that have to be performed are pretty boring. It's not very desirable work, and oftentimes people get distracted and they don't perform the work as well as it needs to be done. The robot doesn't get bored or distracted, doesn't come to work with a hangover. It reliably and consistently gets the job done right. And it has the right sensors to do the job correctly too. So it's really a good combination of helping people to do more meaningful work and doing the boring work better. One thing that's important to think about too is the economic dynamic. Our customers tell us that when they improve the quality of the inspection work performed in their facilities by deploying our systems, they find that they can increase their revenues because they can increase equipment uptime. They can reduce unplanned outages and generate more revenue, whether it's a power plant that's producing electricity and can keep producing electricity because they don't have breakdowns, or if it's an aluminum rolling mill that doesn't suffer an unplanned outage that damages inventory and takes a rolling line out of action for a few days. Just the other day, a data center customer of ours told me that they had a small electrical failure that caused them to lose several $1 million of revenue because of downtime caused by that small outage. And they wish they had a robot performing inspections, which they didn't in that area. Cost reduction, of course, is another great outcome of deploying a robot. And we have one customer who had a fantastic result of deploying a robot to carefully listen to bearings in their chemical plant. They had previously been replacing all the bearings in their pumps every 3 months, right on schedule, thinking that was the smart thing to do. But we helped them to discover that, in fact, they were replacing the bearings 5 times more frequently than they really needed to, by carefully listening to all the bearings and learning when the acoustic profile of the bearings changed. And they discovered that they could simply listen to the bearings, and when the sound of the bearing changed, they scheduled the replacement, and it ended up being about 5 times less frequently, and they saved enough money to pay for their robot in just that one discovery. They also reduced their environmental footprint, because every time they changed the bearings, they used solvents for cleaning, they used grease to repack the bearings. So we find time and time again that deploying the robot and improving the inspection systems can save unexpected downtime, increase revenues, reduce costs, and of course, increasing safety is another goal that we feel very strongly about, and that's generally achieved mostly by taking people out of hazardous areas where inspections need to be performed. I'm a big proponent of the whole concept of legged robots. There are other legged robots on the market. I'm not here to sell you on ours today. I just appreciate the opportunity to kind of educate about the potential of these platforms. And this is really what they are. This is a all-terrain mobile sensor platform. Most of our customers, of course, have lots of sensors installed in their facilities to monitor equipment, but it's almost always impossible economically to monitor everything in a facility that really needs to be monitored. And that's where having a mobile inspection platform that can carry a sensor to a piece of equipment is advantageous. Not only can a robot like this deliver a sensor to a piece of equipment that isn't otherwise monitored, but it can also take a sensor to a piece of equipment that is monitored and help to ensure that the monitors or the sensors in place on the equipment are properly calibrated. We've had some customers come to us and ask us if we could deploy a certain kind of sensor in their facility, and I've asked them, well, don't you have hundreds of those installed around? I can see them. And they said, well, yes, we do. The problem is they frequently go out of calibration, and we don't know when they go out of calibration. So we would like you to be able to carry around a reference sensor to help us to identify the sensors that are installed that are no longer properly calibrated. And so that was kind of an eye-opener. But the neat thing is, with a platform like this, we can go almost anywhere, indoors or outdoors, in most industrial facilities, and we can deploy the right sensors to collect the data that customers need. Of course, as I mentioned early on, the robot is, it's an interesting, engaging part of a broader system. And in our case, and it's a standard setup, there are several other pieces that are involved, starting with the software that we use for managing the robot, for programming the missions, for administering a fleet of robots in the facility. And then we also have remote control software that runs on mobile devices. Luca earlier was driving the robot just with a tablet he had in his hand. And then we also have a data navigator platform that is a web app that allows our customers to take the data off the robot, do some analysis, do some trending. It's kind of a quick and easy tool for consuming data. But then the data navigator also has an API which allows our customers to push data into their other enterprise systems for asset management, for work management, and further analysis. So that's a typical architecture, and I always argue that it's the whole system is what that creates the value for our customers, but the robot's the sexiest part. The software is a critical part, but it's not nearly as interesting to look at. I should also point out, as you can see on this slide here, we actually have two models. This is our Model D, which is the IP67 sort of general purpose industrial robot. And the gray one that you can see on the screen is our Animal X. And it's the world's only ATEX certified intrinsically safe legged robot. It's certified for use in potentially explosive environments that you typically find in oil and gas facilities and chemical facilities, and even in places like biofueled power plants where they have a lot of wood dust that can create combustible environments. So those are the two products that we offer. We're very focused on legged robots. We don't do wheels, tracks, nothing that flies, because we're real believers in the universal nature of legged robots. This slide's got a couple of interesting things I just want to point out to you. Number one, I've talked about agility, and you can see on the video on the left some interesting examples of animal dealing with terrain challenges, whether it's things like just rough soil, or in this case grass. Here's a video of snow, soft terrain, and this is a video a customer sent to us from Finland of animal walking on ice in their facility. They thought it was entertaining, so they took a video and sent it to us. But the robot's very adept at sensing its environment and adapting as needed. The other thing that I probably haven't stressed quite adequately is that Animal was developed from day one to be an autonomous industrial robot. That means that it was focused on indoor and outdoor performance, but autonomous activity that's pre-programmed, where all of its paths are identified and tested, all the inspection points are programmed, and the robot can act entirely on its own. Of course, it can also be remotely controlled, especially in cases like emergency response, when the robot needs to go to a point of an incident and evaluate the state of things and ensure that it's safe for people to enter. Here in the lower left is what I was referring to earlier, how we train the robots in a virtual environment, courtesy of our friends at NVIDIA, as you can see. But as you can see here, we can deploy thousands of virtual robots that are very accurate physical models of our robot in thousands of virtual environments, whether it's stairs or random environments, random terrains. And the robots are scored based on their ability to develop, on the basis of trial and error, methods for overcoming the challenges. On the little video on the right, you can see some of the more extreme performance that the robot is capable of. Of course, in commercial applications, we don't usually ask the robot to perform these kinds of feats, but you can see that the hardware is physically capable of some pretty amazing capabilities, like opening the door with its leg, as you saw there, and then surmounting these obstacles that are really much more extreme than you'd typically find in a commercial environment. So that concludes my presentation. I'm more than happy to entertain any questions. You're welcome to come up and take a closer look at Animal. You're welcome to come visit us at our booth. And as I understand, this is the last presentation of the day. I hope you'll stick around for the karaoke that's going to follow, I understand. Is that right, Olivia? Karaoke? No, I'm just kidding. But it's been fun being with you today. Are there any questions I can answer? Yes, in the back. Typically, the entry cost for this particular model in this configuration is about $300,000. And we rent them for around $10,000 a month. I'm a huge fan of a rental model because, frankly, it leaves us as the manufacturer on the hook for performance delivery. And I think that in many cases it makes it a much lower risk proposition for customers to try out how our systems work in their environments. Any other questions?
I'll take another one. Have you thought about some sort of deployable snowshoe for some of those extreme environments?
Well, that's a great question. In fact, I was just talking with a major grain processor the other day, and they asked us if we could make corn shoes for the robot. But no, that's a great question. Many different kinds of feet actually have been developed for the robot. And snowshoes would make sense in situations where the snow was so deep that the robot couldn't, poke its foot down to the ground. They haven't been developed as far as I know, but recently our friends at the Technical University in Zurich, where the robot was originally developed, actually put special feet on the robot and trained it to climb ladders, which was a feat that I never expected to see. But I think you're onto something. The right foot for the right job can definitely open up new performance opportunities. Another question over here?
So if I was to purchase one of these beautiful beasts, does it come with a developer kit so I can customize this function?
To a certain degree, yes. We actually have different offerings for different kinds of customers. We sell a fair number of robots to universities and research institutions, and we have a sort of a special developer pack for them. Typically, our commercial customers aren't interested in that kind of access to the robot's innards, but our Data Navigator tool set, if you will, provides both the data viewing and trending and analysis tools I mentioned earlier, as well as a full API so that it gives access to the data coming out of the robot and allows for things like remote control over mission scheduling and that type of thing. So yeah, there's a full range of ways of interacting with the robot depending on your needs. Yes, ma'am. He'll bring you the microphone here.
Oh, sorry. Has he been tested in extreme nature terrains?
Absolutely.
Like volcanoes, very steep inclines, like Mount Everest type situations?
Yes, yes. We're very fortunate. In Switzerland, we have a huge range of terrain for testing, including a military testing area that we have access to with collapsed buildings and rubble piles and things, and a lot of natural settings as well. And we have very clear specifications about any gradient limitations and even stair dimensions that we can guarantee performance on. So yes, we've done lots and lots of testing, both in industrial environments as well as natural environments. Yes, one more?
Yeah. Does your maintenance for regard to the robots, is it adjusted based on what kind of work they do? Do you have a regular, whether you rent one of these things?
The actual maintenance of the robot?
Depending upon what kind of work they do, if you rent one of these robots, do you then determine what kind of maintenance will go with that robot? So if they're in the hazardous terrains, I would imagine you would do more maintenance than you would do if they were just doing, let's say, maintaining facility in a standard production plant.
Absolutely, yeah. And just sort of to illustrate that, the main wear item on the robot are these rubber feet. And depending on the surfaces that the robot's walking on in its day-to-day work, they may or may not wear quickly. If it's walking on carpeting all day, they would never wear out. But usually they're walking on rough, mixed terrain, and maybe once a year the feet have to be changed. Other than that, though, the robot's extremely low maintenance, and part of that is because it's IP67 and it's really impermeable by any water or dust or anything. So they're very low maintenance, but absolutely, we'll take a look at the environment and make recommendations. We have customers who wash the robot multiple times a day, for example. If it's in a very acidic environment or a very corrosive, dusty environment, it's not uncommon for customers to wash the robot off after every shift. And so yeah, when we commission the robots, we send field engineers to work with the customer to evaluate the situation and make recommendations like that. Thanks.
Hey, quick question. Yeah. What are your thoughts about the robots that came out of China recently, maybe 2 or 3 months ago, that actually had wheels on each paw? And they were extraordinarily agile, quick, and they'd fly around all over the place, but then be able to do incremental moves as well.
I think wheels on legged robots is a really interesting innovation. And in fact, if I'm not mistaken, that was first developed at the Technical University in Zurich on our platform. There is a Swiss company that is now offering wheeled systems that were originally developed on our platform on Chinese robots. I think it's a clever innovation. It's obviously a much more efficient way and a faster way of navigating simple terrain. It'll be interesting to see how it catches on, but I certainly think it's worth paying attention to. It's a nice hybrid, if you will, sort of the best of both worlds. It's hard to argue with the potential utility of that. I think time will tell where that makes sense and where it doesn't. Any other questions? Great. Well, thank you all very much for coming today. It's been a pleasure.